Okay, the next thing that I want to take you through today is investigation 19, staircase problem. Because this investigation is going to lead us to talk about kind of the next big topic in this unit. And it relates back to some of the work that we've done on these kinds of number pattern things in the past. So here's the scenario, right? It says children were building a staircase with wooden blocks. The first step was built, I think it should say, with 1 block, the second with 2 stacked blocks, the third with 3, and so forth. So you've got this picture, right? So this is the first step, and then a 2-step staircase would look like this with 1 block and then 2 blocks stepped on top of each other, and then this is a 3-step staircase and so forth, right? Our task is to write a number sentence for the total number of blocks needed for each staircase for figure 1, 2, 3, 4, 10, 100, and n, like we're usually asked to do, right? And then it has a couple of bullet points to discuss how to find the total number of blocks needed for each of these staircases. And then it asks a question, if you need 210 steps in your staircase, how many total blocks would you need? That's a question that we can answer after we've completed this first task of writing a number sentence for the total number of blocks. So let's focus our efforts on that first. I'd like for you to pause the video and kind of grapple with this problem for a little while. And remember, you can manipulate numbers, you can manipulate the blocks, you can move blocks around, you can, try to see what pieces are missing, whatever, right? Any of the techniques that we've used before, and any other creative thing you can come up with to try to figure out how many blocks are in figure n is going to be useful. So go ahead and give the video a pause and see what you can come up with. Okay, so here's what I'm going to tell you what I think the tendency is to do. So the tendency is for students to say, well, here I have 1 block, and then here I have 1 plus 2 blocks, and then here I have 1 plus 2 plus 3 blocks. And so they say, well, this is 1 plus 2, this is 1 plus 2 plus 3. And then they say, oh, so I've got a pretty clear pattern, right? Figure 4 is going to be 1 plus 2 plus 3 plus 4. And so then they can guess, well, figure 10, of course. Figure 10 is just going to be 1 plus 2 plus 3 plus ... plus 9 plus 10, right? Now, this is correct. It's not wrong. It's just that it's not very useful, right? Because we would like a formula like the ones that we've been coming up with, right? Where we can just plug in the number and get the answer pretty quickly. Where if you're doing like 1 plus 2 plus 3 plus all the way up to 10, that's a calculation that's going to take you a long time to figure out. Generally speaking, any formula that uses the ... thing in it, that's not a closed form. That's not a closed formula. We want a closed formula, right? We want one that we can just plug the figure number into the formula and boom, get our answer. So this is not terribly useful. And as bad as it is for figure 10, imagine for figure 100, right? If you actually wanted to figure out how many blocks you would need in figure 100, and you were trying to figure it out this way, you're going to be here all day long adding up those numbers. And for figure n, in general, you could say it's 1 plus 2 plus so forth, all the way up to n, I guess. But these kinds of formulas are just not very useful. We want to come up with a closed formula here. So if this was the technique that you used, if this was the formula that you came up with, then I would invite you to pause the video again. Go back to the figure. See if there's some kind of way that you can manipulate this figure to come up with a closed formula. Okay, and by a closed formula I mean something like, n plus 1 times n plus 2, divided by 3 or something. I don't know what the answer is going to be, but that's what I mean by a closed formula. Not something that requires you to add up, 100 numbers, right? So give the video a pause, see if you can come up with a closed formula for this. Okay, so I'm going to walk you through maybe some things you might have thought of. One of the things that occurs to me immediately is that if I just try to fill in this figure with what's missing, so I'm missing a 1 there. Here I'm missing a 3. Okay, so I can get what's called a recursive formula out of this. That is, I can describe how many squares are in figure 4 if I know how many squares are in figure 3. And I can figure out how many squares are in figure 15 if I know how many squares are in figure 14, right? So recursive formulas have the same problem as this. So let me just show you what the recursive formula would look like for this. Right, so figure 1 is 1. Figure 2 is a 4 by 4 minus a figure 1. And figure 3 is a 3 by 3. I think I called this a 4 by 4, but I meant a 2 by 2. Figure 2 is a 2 by 2 minus a figure 1. Figure 3 is a 3 by 3 minus a figure 2. Notice that it's not a figure 3 minus a 2 by 2, because I'm not missing this square right here. Okay, I'm only missing these 3. Okay, so I'm not missing a 2 by 2. I'm missing a figure 2. Right? If you take figure 2 and you kind of turn it upside down, that's the piece that I'm missing on figure 3. And we could kind of, if we draw out figure 4, we can see kind of how that pattern continues, if it continues. Okay, so there's figure 4. Now what are we missing? We're going to be missing, I'm going to use a different color. So what are we missing? We're missing, well, notice if you take figure 3, flip it over, and that's what you're missing. You're missing a figure 3. So figure 4 is a 4 by 4 minus a figure 3. It's not a 3 by 3 that you're missing, because you're not missing these 3 pieces. You're only missing these ones that are kind of outlined in red. Okay. So we might be able to fix that up, though. I mean, I think it would take us a little bit of thought to kind of fix it up. But you know, potentially we could fix it up. I'm not going to bother like trying to you know, figure this out, I guess. But in general, I think what we're seeing is that a figure 4 was a 4 by 4 minus a figure 3, and a figure 3 was a 3 by 3 minus a figure 2. And a figure 2 was a 2 by 2 minus a figure 1. So I think in general a figure n is going to be an n by n minus a figure n minus 1, right? The figure that came before it. So again, you can see why this particular formula is not particularly useful in the format that it's currently in, because, well, in order to know figure 100, you would have to know figure 99. So it's not like a nice formula that you can just plug stuff into. So that doesn't quite work, but here's the secret. You're really close. If this is kind of the idea that you came up with, you're really close. If you just go one additional row, then I think you've got something very nice here. And I'll show you why. If we go one additional row, because notice if you go one additional row, then what you're actually stacking on top of the original figure is just a copy of the figure, right? Like if I copy figure 3 and flip it over and then stack it on top of itself, this is what I get. And you know, same thing for figure 4. So I guess for figure 4, what I would really want to do is make an additional row. And now I've just got a copy of figure 4 stacked on top of itself. Now, why is that useful, you might wonder? Well, let's work this out. If I do the same thing for figure 1, so what I've done is I've just stacked each figure on top of itself. So if I do the same thing for figure 1, I guess this is really what I have. Now, why is that useful? Well, because now I can describe the figures this way. So for figure 1, I can describe this as a 2 by 1, right? Figure 2 I can describe as a 3 by 2. And figure 3 I can describe as a 4 by 3, and 5 by 4, and so forth. And I've doubled the number of squares in each figure, so it's going to be, you know, that number, but then just divided by 2, right? Because I only have half, because I only actually have half that number of squares. Let me write down what it is I'm saying. So if I write down a number sentence for the figures the way that I see them when I've drawn in the additional squares, right? This would be, like I said, a 2 by 1. And figure 2 would be a 3 by 2. And figure 3 would be a 4 by 3. Okay, and figure 4 would be a 5 by 4. But now here's the secret, right? That's double counting the number of actual squares, okay? Because if I call this a 3 by 2, it's like, yeah, they're 3 by 2, but I only had half that many squares, right? I only had like this figure to begin with. So I've double counted the squares. So I can just come back and say, take half of that number, right? Same thing for figure 3. I can just say, well, it's 4 by 3, except that in actuality I only have half that number of squares. And same thing for figure 1, right? It's a 2 by 1, but in reality I only have half that number of squares, so I'm dividing by 2 each time, right? We can verify that this works, right? 2 times 1 is 2, 2 divided by 2 is 1. That's how many squares I had in my original figure, right? 1. For figure 2, 3 times 2 is 6, 6 divided by 2 is 3. And sure enough, that's how many squares I had in my original figure. For figure 3, 4 times 3 is 12, 12 divided by 2 is 6. In my original figure, I had 1, 2, 3, 4, 5, 6 squares. Okay? And same thing for figure 4. So this we can extrapolate, and this we can get a closed formula for, right? So we can say dot, dot, dot. Now for figure 10, what's it going to be? Well, it looks like figure number plus 1, right? So figure number plus 1 times figure number divided by 2. And so, extrapolating now to figure n, it's figure number plus 1 times figure number divided by 2. And there's our closed formula, right? Now we can say, without having to sit here and add up 1 plus 2 plus 3 plus 4 plus all the way up to 100, we can just say, well, for figure 100, it's going to be 101 times 100 divided by 2. That's the number. That's the number of blocks that you need for figure 100. And for figure, so if you want 210 steps, that's figure 210. You can just plug in 210 to this formula. It's going to be 211 times 210 divided by 2, and that's the number of blocks that you need. That's the number of blocks that you need in figure 210 for if you want to build 210 steps. So so that's the way that works. That's the way that visualization works, and this is going to be an important visualization to keep in mind as we look at this concept in a slightly different way. And so we're going to look at this concept. I'm going to start a new video, but we're going to consider this concept in a slightly different way. So so stay tuned.